Okay, so we'll go back now. Sorry about that. There we go. So we were saying every single thing that exists is made up of atoms: metal, wood, us, like water, everything that we can think of. But they're like those tiniest little building blocks, the Lego pieces. So, like, do you know that, like, the one stud Lego piece? If I was to give you a big huge bag of them, like, you could make whatever you wanted out of them, but they would all be made up of that repeating pattern of the one little Lego piece. So atoms are kind of like that. Like, they join together in so many different combinations, they can make up anything. But if we were to get these tiny little microscope and we have a look in at an atom and have a look at what it's made of, you'll see that you probably have seen a picture like that. They often use it when they're describing science, right? So inside that center of the atom, right, we call, like, right there, right in the center of the atom is a thing called, we call the nucleus. And in that nucleus, so like in the nucleus is this stuff called protons and neutrons, and then, like, whizzing around like a shield. I kind of think of it like in a Marvel movie or something, when they have a shield around them protecting the nucleus, and whizzing around it are these orbitals. And in those orbitals, we've got things called electrons. And that's what electrons, they're what we're really interested in now for the moment. So if we have a little look, so right, we said in the center, we've got these things called protons and neutrons, and then whizzing around, we've got electrons. And here's the thing, right? Because of that shield going around the atom, the orbitals, you can't really, you can, but it's really, really hard to get to the center of the atom, to get in at the nucleus. Like, it's very difficult to get in at it. But the things, the electrons in the orbitals, that's a little bit different. They can move around a good bit. So if I had, like, this is like think about it like in maths, right? If I had 3 protons, 3 positive charges, and I had 3 electrons, 3 negative charges, what I would say is that that atom is just 0, or it's neutral overall, because it has the same number of both. So the thing is, right, atoms can lose electrons or it can gain electrons. So they're able to do that. Atoms are able to lose some of their electrons or gain more electrons. And this, like, bear with me for a second, because this is probably this. Oh, I'll go back here for a second. So if I was to lose electrons, so see that little atom there, if it now only had 2 electrons, well, then it'd be more positive than it would be negative. And if I was to gain loads of electrons, it would be more negative than positive, which probably all sounds very confusing. So I'm going to show you something else I'm going to go on and show you something else for a second that might help with it. So back to what has that got to do with a trampoline? Okay, so if we have a look at this. Now, what I'm going to check when I go on to this, you have to, sometimes it doesn't stay. Is it still? Oh, it's still sharing, is it? You can see something called John Travoltage, I think. Can you? I'll just check that someone put it in the chat for me if you can still see a video of something with John Travolta, or a thumbs up. Yep, we keep going. I presume we can still see it then, okay? So kind of like the trampoline, right? And we'll bring this whole story together. So if we're made up of atoms, and generally we're neutral, we're just 0, but we can, by friction, go around and pick up extra electrons, or we can lose electrons. And how would we know that that's happening? That's where, like, if you've got this, like, your hair would start to stand up because all of the electrons are trying to get away from each other. Or it's back to what we said on the trampoline. Then when you touch the metal of the trampoline, you're trying to get rid of those extra electrons. So if I have a look here, right, and this is funny, this is a funny kind of video, right? So if at the moment he's just neutral, and then them. So what happens is, so you gain the extra electrons, but then you find a way to get rid of them, right? So if we say, if his hand was pointed up there now, look, all the extra electrons building up. But at the moment, they're all just building up, but they can't go anywhere, right? They're not able, look, they're just stuck there. But there's something, if you find a particular material, the electrons leave and they pass through to that material, and there's a tiny little shock happens, like a little static shock. But in fact, that's kind of the basis of any single thing, right? So if you look at it there, what happened was electrons built up by friction, and then the electrons moved and they jumped over to the handle of the door, because I'll tell you a little bit more about that in a second. So any single time, this is the bit that I can tell you now, it doesn't matter, you can know this forever and it won't matter which example you're looking at, right? Every single time we get, so electricity by the word means electrons. So electricity is electrons that are moving. So every single time that we talk about electricity, it doesn't matter if we're talking about using batteries, if we're talking about solar panels, wind turbines, hydrogen fuel cells, hydropower. Every single time what we're doing is we're getting electrons to start moving. And really what we're interested in this program, what we want to look at is, well, where will we get those electrons from? Can we get them from somewhere that they'll never run out? That we probably call them green, I suppose we call them green electrons. So the big thing for us, what you want to look at is, how do we get those electrons moving, and where can we get the electrons from? So I promise you that's the kind of hardest part. And if some of that didn't make sense, really don't worry about it, but it's just good for me to tell you the full story. So if I go back here again, because if you hear it a second time, it might make more sense then. So we said, look, so basically when we talk about static electricity, you ever do the balloons and you rub the balloons off your hair? That's just because they're losing and gaining electrons. And there's another little video like the one I showed you, maybe your teachers would show you through the FET simulation, that you can get the charges to build up on balloons and stuff like that. The difference between static electricity and what we are going to look at is, static electricity is when the charge builds up on something, but it's not really able to start moving, or it's only a little bit of it is able to move. It kind of just builds up around the material and then generally just disappears back into the atmosphere. Where what we want to look at is, so you can see that there. Yeah, look, talking about electric. Oh, we had a look at that. Sorry, no. So we're going to look at current electricity, right? Which is the movement of electrons all the way around circuits and stuff like that, right? It's really when we get electrons to really start moving. So I'm actually going to stop sharing for a second, and we're going to look at it this way. If I use, right, my basic battery, and this is what's in your kits now. You've got in your kits some of these battery packs, right? Except there's a cover on yours. I've lost my cover. When you see now, and you might look at it differently, right? When you look at a battery, you know the way it says plus and minus on it. So the plus and minus is telling you what way you put it into the battery pack, right? But the plus and minus is actually telling me inside of that battery, that's what the minus is telling me, that there's millions of electrons stored inside of this battery. So this battery is like a storage of millions upon millions of electrons that they want to get out and start moving. So we have to help the electrons to start moving. They won't just start moving on their own. So if we looked at, right, how can I get these electrons to start moving? So it's kind of like the static building up, but they're stored inside of there, and they're stored in what we call chemical energy, because that's just the way they're stored inside of it. So I'm going to have a look and see, can I start to get those electrons to move? And what I'm going to do to have a look at doing that is, first of all, I'm going to try and get them to move and light a light bulb for me. And again, you have these in your kits, right? So these light bulbs are called light emitting diodes. So you've probably come a few years ago, nobody really used light emitting diodes, but now we use them everywhere, because even in those strips you get for bedrooms and stuff, they're all light emitting diodes. And the thing with them, there's a long leg and a short leg. And I'll tell you, if you can see it on the screen, can you? I'll tell you a little bit more about that in a second, because that's important as to how we connect it. So if I'm going to start, right, so I'm going to try and get this light bulb using the energy. So I'm going to try and get the electrons in here to do some work for me and let them get moving. So first of all, I'm going to click on a crocodile lead, and I'll start by clicking it on. I'll click it on there to the metal part. So the metal. So look, notice I don't put it onto the plastic, and we'll talk a little bit more about that. But I put it onto the metal part, or the wire part of the crocodile lead, and then. So And I'm going to put it on. I'm going to put it on again. Look, I'm going to put on a second one there. But what you'll see is, right, what's happening now is what's really wanting to happen is the electrons want to come out one side of the battery, and they actually want to find themselves a loop to get to the other side of the battery. So that's really what's going on. Those electrons want to get out of there. So they want to come out one side, but they want to go back in the other side. So at the moment, you see there's that gap. See, there's a full gap in the circuit, so they can't, or a full gap in what we've made. I know it's hard to see, and I'll show you on the picture in a minute. So I'm going to put in a second wire, or a second crocodile lead. I have to put it down. Right, now I put in a second one, and there hopefully you can see that my light bulb is lighting up. So what we've discovered, or what we've looked at, right, what we've basically is that what we're after doing is we've managed to get electrons to start moving around for us. So we've managed to get our electrons to move. So what they're doing is, if we could see this now, those millions of electrons, they're after kicking out into the wire, and they're pushing along the electrons that are in the wire. Every time they pass through the light bulb, they give that some energy and the light up, and then they come all the way back around. So if I want to get electricity to generate, and I wanted to do something like I don't know, light a light bulb, power a robot, a drawing machine, an electric car that you might make in the classroom, every single time it's the same. It's like, so we've said electricity is always the movement of electrons. In order to get those electrons to continuously flow and do work for us, there's three conditions we need. We need to have an energy source. It needs to be in a continuous loop, right? So we need an energy source, continuous loop, something to carry that energy. But there's one other bit we need, and I'm just going to show. I'm going to put, and I'll show you this in pictures, because you'll be able to do it in the classroom yourself. It's just quite tricky. And I say it's quite tricky on screen, right? So you see there now, I don't have my continuous loop, look. And when I join it and I have the continuous loop again, the light bulb comes back on. So when there's a gap in the circuit, so when that gap is in the circuit, the electrons, those electrons can't get from there over to there, basically. That's the problem. That's what's going on. They're stopping there and they're not able to get all the way across. So what I would ask you, well, what if I was in a situation now and I can't, like, that can't reach and it can reach, but what could I put there that would bridge the gap in the circuit? What type of, could I try different materials? I don't know. I'll have a look. What if I put in some plastic? What do you think? If I was to put in, I'll try it. If I was to put in plastic, do you think and I connected it, do you think the light bulb will come on? You can't really answer me there, or do you think the light bulb will stay off? Well, you can see, because our science is telling us, isn't it? In this case, the light bulb is staying off. So that material didn't allow the electrons to pass through. What if I tried, I have a piece of tin foil here. What if I tried a piece of tin foil? What do you think will happen? See, it doesn't matter what you think until we actually do it. Oh, I've done some actually now. So that's surprising me. I put in tin foil. Do you know what? I'm after putting in tin foil. I'll tell you, you can discover this. You can check this for me yourselves. I've put in tin foil and the light bulb didn't come on, which is actually really surprising, because I really thought the light bulb would come on with tin foil. And I'm wondering how my battery's gone, which looks to be the case. Isn't that typical? Look, I'm after burning the batteries out. So when I change them now for a second. So I'll come back to that in a minute. So we're saying for electricity to flow, we need energy, we need it in a continuous loop, and we need certain materials to be able to carry those electrons around the circuit. So in terms of, right, again, if the kind of science bit and you're like, I don't know what all that means, doing your experiment is the most, doing the experiment is the most important part of this, to figure it out. So we're trying to get electrons to move. So you see the picture there that it's telling you, you need energy, you need it in a continuous loop, and you need something that carries that electricity. So when I put in, well, something's gone wrong in mine. I'd have to blow in the light bulb in some way when I have a look. So when I put in the plastic, it didn't conduct electricity. When I put in tin foil, it didn't conduct it either, even though I really thought it would conduct electricity, but for some reason, I'm just trying to fix that circuit. So you know the way, like here, mine, yeah, I think my batteries are gone. So mine here, when I didn't get the light bulb to come on, I know I can problem solve that because I'm just going to try and change, because I know if I've got energy, I know if I have it in a continuous loop, and I know if I have conductors and something's not working, well, I can kind of try and figure out why it's not working. Then I can have a look at it myself and figure out why it's not working. I'm just going to change batteries here for a second. Anyhow, so it's decided not to work for you guys, so we're going to have a look at a different one. So we said current, electricity, we need an energy source, we need a conducting material like the metal, and we need a continuous loop. So if there's a gap in the circuit, the light bulb won't come on, or the motor won't turn, or if it's a little robot or something, it won't work. So if there's a gap in the circuit, then it actually won't flow in a continuous loop for you. So you see it there, look, do a continuous loop. What about, okay, I'm going to stop sharing for a second. So we looked at, we said a battery was a source of chemical energy. Well, what about, and these are in your kits as well, what about this one? Oh, someone's out, sorry, I'll let them in. So what about this one here? So if this is an energy source, let's try the same way again. So we're going to connect the light bulb. So what did we say? We need energy, we need it in a continuous loop, and we need a conductor to carry that energy. But I have all of that and the light bulb's not lighting. So why would the light bulb now, in this case, why might the light bulb not be lighting? What do I not have? What might this need? So that one is actually a solar panel. So we can't get this. It's going to produce electrons, but it won't produce electrons until it gets some light. So the light energy hits it. Now, unfortunately, on the screen, I can't stretch it. It's a beautiful, I'm in Wexford and it's a beautiful day here today. And if you have the sun out in your school, you could try these straight away in your kits, because even if I could get it closer to the window, the light bulb is lighting. Oh, you might see it there now. The light bulb, with sunlight's coming in the window, and the light bulb is starting to come on. When I take the sunlight away, look, the light bulb is coming on. When I take the sunlight away, the light bulb goes off. It's the very same as the battery one. So it's got the energy, continuous loop, and a conductor to carry that energy. Then we have another one. Let me have a look at this one. Oh, look, it's brighten up right away. So you could find out how many ways can you light a light. Look, here's another one now. I've got the light bulb and I have it in a continuous loop, but now I have this as an energy source, but the light bulb is not. So the light bulb is not coming on. So is it not? What if if the light bulb is not coming on, it mustn't be producing electricity. I think that's fair enough, isn't it? Because we said that if the light bulb was coming on, it was definitely producing electricity. So in this one, if I give this little spindle on, look, that's a little motor, but motors are actually generators as well. And I'm not going to go into that too much, but every time I keep spinning that, every time I'm spinning this little motorized bit here, the light bulb, it might be hard to see on screen for you. Oh, there you go. The light bulb is coming on. So I wonder if that's anything. If I could keep that thing spinning, if I was managed to keep that spinning for ages, would the light bulb stay on? And that might be something you come back to later. We're not going to go too much into it. But we've said battery powered, solar powered, hydro powered, mechanical with me doing it with a generator, they all have the same thing. They're all producing electrons. So when they produce electrons and we get those electrons flowing around, in every single time we get that generates electricity. I suppose the difference in my battery powered is that the battery, unless it was a rechargeable, the battery is going to run out. In the one I showed you here, what's the difference? It's never going to run out as long as the sun is shining on it. So that's more of a renewable energy source when I'm using the power of the sun. And this one again, this one I've showed you here, that's the kind of the same. If I can keep that moving all the time, well, it's not going to run out. It's just how could we come up with how could we come up with a way, like that's you working as an engineer or a scientist, how could you come up with a way to keep that moving all the time so that it keeps the light bulb lighting up and it doesn't run out? But just so we can, I'm going to show you one, I'm just conscious, we're good for time. I'm going to show you one more thing, so it might help explain that, just to show it to you a little bit better. I had these open and then I closed it. Now, okay. So I'm going to open this again to show you. So we're saying, let's have a look at it. So in case it was hard, in case it was difficult for you guys to see it, when I was trying to demonstrate it with the one on my thing, right? So I'm going to show you what I was talking about now. So if we take, right, so we're trying to get electricity to flow. So I'm going to take a battery there, and into my battery, then I'm going to click on a wire. That's what you saw me do. And I'm going to put on another wire. I'll just move these down a bit so that they're easier for me to use. I'm actually going to just put on another wire just so I'm easier for me to connect it. And I'll put in another wire there. And I'm going to slip in a light bulb. Look, I'm going to pop in a light bulb. So at the moment you can see, look, see the little minus signs? They're all the electrons that are there. And in the wire, they have electrons as well. Like, so we said everything was made of electrons, but at the moment there's nothing happening in this case. And the reason there's nothing happening is we have a gap in the circuit there. You see, there's not a continuous loop. So when we have a continuous loop, we get the electrons from the battery start moving. They push the other electrons around the circuit, and every time they pass through the light bulb, they light up. So that's kind of one of your first experiments that you can do, like ones to start with, is first of all, see, can you get the light bulb to light up? But then let me cut. This is what I was trying to show you, and my light bulb decided to stop working. What if I put, what type of materials, like, I don't know, what do you think if I was to put, that's a rubber, if I was to put that in there, will that allow the electrons to pass through? And you can see, look, no, they don't move. They're not able to move. So that rubber, that's not very good at allowing electrons to pass through. So you could try that in your classroom. You could put in different, into your circuit, you could put different materials. I'm going to try a coin. Let's just click it on. What do you think? What do you think about the coin? So there's a gap still in the circuit there. So I better fix it and put it in. And you'll see the coin allows the electrons to pass through. So when that happens, we can light up our light bulb. I'll try one more. So let's have a look here then, right? So basically every time, I don't know if that would work. I don't think, I was going to try and show it just a different way, right? So basically a switch being added to the circuit, and you could try and make a switch. There's a lesson in that you make a switch in a circuit, and you hear that even if you turn on your switches in the classroom. A switch in a circuit is where it makes a gap in the circuit. So you can see it, look, when there's a break in the circuit. But then what we can do is when we turn the switch on, we flip those two metal bits back together. And when we flip them back together, it closes the circuit and the light bulbs turn on. And then when you open the switch, it stops. So basically the switch stops the electrons from being able to get around. So all of these you can try with the kits that you have. So you can try like power one light bulb, power two light bulb. What type of materials conduct electricity and what type of materials don't conduct electricity? Can you power it with a solar panel or with the little generator? And then I'll show you this one because I think this is possibly everyone's favorite. So far we've only looked at light bulbs, right? So I'm going to go back to my battery again, and I have my wires, my conductors, and this time, and these are in your kits as well, I'm going to put in a little motor. So I connect to one side. And remember we said energy, continuous loop, and do we have conductors? So I'm going to put in a motor. And I don't know if you can see that, right? Because it's going to be spinning very quickly. So you might not be able to see it. So I'm going to stop that for a second. And what I'm going to do is, I think this one is always everyone's favorite. Stop it now for 2 seconds. And on the motor, I put a little bit of blue tack onto the motor, right? And I'm getting a little piece of paper. You could use, I have a circular piece of paper, but that doesn't matter. That's just, you could use a little square, right? A little small piece of paper. And what I'm going to do is switch it back on. I'm going to connect my circuit again a second time. Now it'll probably spin off because of everything this morning has decided to go a bit crazy on me. And I don't know if you can see that, but when I tip on that, I have my little spinning machine. It starts to do a spin art, which it's probably, I don't know if it's coming across on screen, but it's actually really cool when you do it. So when you tip it, it starts to make some art for you. So it's a spin art, but often really disappointed when it stops spinning. Look, it looks completely different. Like it looks totally different when it stops. I still think it looks good when it stops spinning, but it doesn't look as good as when it's spinning. But you could make some little spin art in your classroom and they look really good as a display if you put them up. What I would challenge you to do, right? Here would be my STEM challenge. If you were to do using your kit to make a spin art machine, can you make a switch that you make from some materials yourself in the classroom to control your spin art machine? So with everything we talked about, like how to turn it on and off, like could you make a little switch as an example, right? Let me have a look here. So let me try the tin foil again for some reason when it didn't work for us a few minutes ago. So I'm going to have a look if I was to put tin foil into my circuit now, would my spinning machine work for me? So I'm going to connect it back in. Okay. So you do. So look, I don't know why a few minutes ago the tin foil decided not to work for us. So tin foil definitely conducts electricity because this thing is now spinning like mad again. But it's not working as a switch for me. It's definitely not a switch that I've made there. But what if I don't know, what will I try? So what I'm going to try is, it'll be hard for you to see this now. So what I'm going to do is I'm going to wrap some tin foil maybe. I think, can I make a little switch? You can come up with your own ideas. So I'm going to wrap a little bit of tin foil around this plastic. So I'm going to wrap some tin foil around the plastic like that. I could even stick it down. And I'll wrap another piece, and I'll wrap another little piece of tin foil there. Now, thankfully, for any of your teachers, you'll have this in the notes. So I'm wrapping some tin foil. There's a little gap there. Look, I've just have a little bit of tin foil. And what I'm wondering is, if I was to connect the wire there and there, would that work as a little switch for me? Would that actually do a job as a little switch? Let me have a look. So I'm going to connect one crocodile lead to that side. I'm going to connect another crocodile lead here. But my motor is not turning. Look, the motor is definitely not turning. But when I take that, look, when I press down, when I use like when I press it down, I've turned it into a little switch that I can control. So I've made myself a little homemade switch to turn on and off my spin art machine. Right, so I'm going to, so there's a good, like there's some activities for you to try. First, I would always start with, can you light up the light bulb? Can you test what different material, can you get the light bulb to light? Can you test different materials to see which conduct electricity and which don't conduct electricity? And then what about trying that with a solar panel? Can you try and use your circuits and see, can you generate solar electricity? Or you can can you do that for the spin art machine? The one thing, right, here, I'm going to give a little tip now in the kits you have. And I do this, you could help your teachers. You wouldn't need to do this today. This is what I do. I use these little Ziploc. It's only a handy little tip. I use these Ziploc little bags like this. What I do is I store all my, into each little bag, I'll put my motor, I'll put my light bulb, a few little light bulbs, I'll put my battery pack. I'll put the battery pack into it. and I'll put some of the crocodile leads into the bag. And what I do is when I'm finished them, so even if you take them out and you have all your bits and you're mixing them with people in your class, if you put them back in the little bag, they're ready to go again for your next experiment. Because often what happens, particularly when we're doing electricity experiments, they all start to get mixed up and you can't find any of your stuff, and it ends up with a big, you'll end up like me, look, with a big huge bag of wires all stuck together. So if when you're finished, you wouldn't have to do it today, but if you get some of these little Ziploc bags and you store everything, you've made yourself little storage that they can go. You can just store them away into the box in your bags like that. And it's really handy just for the next time you want to use them or the next little activities that you might want to do. What I didn't talk about, because I didn't want to talk about too much on terms of looking at our wind energy yet, because I really wanted to just have a look at electricity and understanding electricity and how we get it to move and stuff like that. So I didn't go into wind energy, but we could, we'll have a look. Do you have any questions for me that you'd like to ask me before we go any further? Do you have any questions at all that you'd like to ask? Anything? You can pop them in the chat or you can ask. No questions. Are you going to try some of those science experiments yourself? Oh, yes, we look forward to it. Even I did start to think, I hope we're still connected. What I would say to you, right? What I really would say, I'm going to give you a few extra little tips, right? If you're using the solar, because like science with everything, right? If it all just worked like exactly as we thought it would, sure, wouldn't it be great? And we wouldn't have to test things and look at things, but it doesn't. So if you're using your solar panels in your kit, right? If you're using your solar panel, that's absolutely fine. Like as we said, it works the very same as using the battery. You just need to use the sunlight. If you want to power a motor from your solar panel, it won't. Those solar panels are not strong enough to power. They will be given it electrons, but they're just not strong enough to power, say, the little motors that are in your kit. You've got 12 of these type of motors. It looks slightly different. But in order to power a motor from a solar panel, you need to use what's called a solar motor. It's just, even if you feel them you have them in your kits as well, even if you feel them, they're heavier than the other motor, and that's just because they've more gears inside of them to generate electricity quicker. So if you're doing any motors with the solar panels, just remember you need to use the solar motor with it, and it'll work perfectly. I want to see, if I can connect it here. It's just really hard to get them connected where I'm not. If I was in your classroom, I could show you, I could have a look. So anything, like any of these that you can do is you can do them battery operated, then you can do them connecting them with a solar panel, or connecting them, hopefully when you get to that bit, you'll see, I see, like, so I can't get enough light to hit it. So if I'm using this, look, basically I just need to put it in the window and get enough solar energy going to it that would power the motor. So what I would say to you is that, no, it's not. Look, I'll probably start, if I could get over to the window more now, it would go. I'll leave it there for a second. It might start. What I would say to you is, there's another one as well. See how many, do you know, I only put on one light bulb, so I can keep adding additional light bulbs. So if I was to keep adding, I'll just show you, it's easier to show you with this PhET simulation. If I was to keep adding extra light bulbs, right? And it's going to, because this is a great challenge to do in the classroom. So I'm going to add, so say, like, imagine that's our crocodile leads added on, and now I'm going to add another light bulb. So what I'll actually do is I'll add it on to that crocodile lead that's there. I'll clip it onto the crocodile lead, and I'll click it on there. And let's see, can I put in a second light bulb? And look, you can see that we have a second light bulb gone in. So what that's called is a parallel circuit. So what you could do as a class now, you could see how many light bulbs can you light from the solar panel. Can you keep adding LEDs? And if I was doing that, I do it first with the battery to make sure it's working, and then I'd switch it and try and do it with the solar panel. And hopefully by the time you go and build your wind turbines, that you could do it with the wind turbines and see how many light bulbs you can light from the wind turbines that you made in your classroom. But there's your hint on how you start to add them. So you start to add them as parallel circuits. And I just go back and have a look. I see some questions there. Yeah. So where did it go in the battery run? What happens when the electrons go into a phone? Where do the electrons go after that? Where did it go when the battery runs out? So in the phone, right, it's different, isn't it? Because it's the phone batteries are rechargeable batteries. So what happens is, so the big thing that what we say in this, energy can't be created or destroyed. And I'm not going into, because I think the engineers are going to talk to you about this, but we convert from one form into another. So when they run out in the battery, it's not that they've run out in your phone, they've converted fully to like everything. Now, here's my phone. They've converted to all the little jobs that we're doing on our phone. So there's no more electrons stored in that battery to be converted. So in a way, what we need to do in a way is we need to feed the battery. We need to recharge it. So when you plug in your phone, what that does, it takes electrons and pushes it back into the battery to use it a second time. Now, wouldn't it be a really good idea then? Wouldn't it be a really good idea if we could charge our phones using renewable energy? Could you come up with a prototype for that? I was in a school one day, and a student who was in a primary school, and he said, what about having solar panels on your school bags? So like you have a solar panel on your school bag and plug your phone in as you're walking to school. Now I know phones are not really allowed in school, but you could plug in your device because your school bag would help charge it. Another really great idea that I've heard is, what about at bus stops and stuff? What about having the benches there have solar panels on the benches so we could charge our devices and stuff that we need? And I think that's when we're talking about energy and energy transformation, I think that's probably the important thing to say. It's like we need to find a way that we're getting green electrons all the time, because we do use so much we need to, I suppose it's good to cut down on our energy use that we use. But the modern world powers a lot of devices and we use a lot of technology. And I don't think that's going to change. Maybe we'll try and reduce a little, but I think that will stay the same. So we need to find ways of using green electrons. So little green electrons to try and power our devices and our homes in a renewable way, if that makes any sense. Do any other questions? As I said, I'm purposely not really going into the wind energy part, because I think if you have a look at understanding electricity, and I'm going to use the word, actually, I'm going to say, because I often say is that you're playing with circuits and you're exploring them. And what's really important to say is that the electricity that we're using, or your teachers might be using in the classroom with these kits, is really, really small. It's only 3 volts of electricity. So that's why it's safe for you to construct circuits and stuff with it. And that's completely different to like the electricity that powers your school, or the mains electricity. And that's the one that's never, like, I know you wouldn't, but it's just for me to say it. That's the one that's not safe to, like, we don't mess with that type of electricity, but it's these little circuits are safe for you to explore and carry out experiments with. So they're like, you're kind of playing with them and exploring them. And do you remember at the very beginning what I said to you? Even though I went through all of the electrons and talking about all of that, the most important bit is you exploring, like, seeing, can you get the motor to turn? Can you do the spin art machine? Can you power it with renewable energy? Because that's where you're starting to learn all those concepts, that you have a look at them. And if you remember, like, so if your light bulb is not coming on, or if your motor is not working, what you have to think is, do I have an energy source? And is there energy still in my energy source? Is it in a continuous loop? So is it able to travel around in a continuous loop? And are there conductors that allow that electricity to flow through? And no matter how complicated your circuit or something might go, if you go back to that, that's always what will help you problem solve it. And then that's where you can try loads of different things from it. I wonder, what might just see, I'm just going to make sure Actually, I might just finish off this. Sorry, let me just have a finish of this. So look, there's everything. There's just to show you everything we've been talking about. That's just a basic circuit that we were looking at. Then what we were saying, look, when it's an open circuit, the electrons can't get around. Basically, that's what you're thinking. Those electrons are not able to jump through there and get back into the battery. They can't get fully around in a loop. And then that's what we were looking at. Look, your base control the electrons. So a little switch does that. So your switch is a way to stop the electrons and then allow them to let them flow again when you want them to be able to flow. And then that's what I was trying to show you. Look, I didn't go into series circuits, so we don't worry about. So the parallel circuits is where you keep lighting. So your Christmas lights are parallel. You could use use all the lights now in your kit. You could do a solar powered Christmas tree and make one for your classroom. There's an idea. So if you use a parallel circuit, you can keep adding light bulbs onto it one after the other, and you could try that first before making a prototype for it. That's just, look, it's showing you the way they click on. Actually, I think for your teachers in the notes I sent you, it shows you how to connect it for the parallel. And sorry, that's only, look, that's just, this is what I was going to tell you, sorry. When you're collecting the LED, remember I said that at the beginning, it has a long leg and there's a shorter leg. If I had the old fashioned, like the older filament bulb, that doesn't matter if it goes to the plus or minus of the battery. The filament bulb or the LED, it does. So the long leg needs to go to the positive of the battery. So the long leg goes to the positive of the battery, and you'll see it in the notes as well. The easiest way to say it to you, if you've everything, see like the middle picture, if you've everything connected like that, but your light bulb is not turning on, then just flip it around. It's kind of like just turn it. You might have the plus to the plus and the minus. So just flip them around and connect it the other way is the easiest way to explain it. And that was just the one I was showing you. Next time is I'll stop sharing there for a second. Do you have any other questions for me there? I think now, how long did it take to figure out how to make a windmill? How do we make a mill? Okay. Do you want to? So the reason I started today with just covering, like, so that everyone had a good understanding of electricity and circuits. So in terms of making the windmill, the lesson plan I sent you for that, you could absolutely start with making the windmill. That's totally up to yourself. I just thought we would be better that we all had an understanding of electricity and getting that understanding of the circuits before. But if you want to go straight into, look, like, I don't know if you were here, that's they're the windmills, and there's some of the prototypes. So I did send you on and the lesson plan and the picture guides for that. So if you didn't get it and you want to email me and that's where you want to start with, that's absolutely fine. That's totally up to yourself. And I think, as I said to you, with all of this, there's so many in those kits. There's so many different activities you could do. You can design the windmill. You can power it like that. You generate electricity. You can build drawbots. You can make a pop-up Christmas scene. Like, it's designed for that. It's not designed that you have to do it all in one go. It's up to you. Like that, you might, like the solar power. You might make solar powered spinning machines or solar powered drawbots and do them maybe later in the year. So it's more that you have that as a resource for your classroom, that you can use it whenever you want. The reason I started with this bit and not straight into the windmills is just that I think it gives a good understanding of us all understanding energy and electricity before jumping into wind turbines, if that makes sense. But if you didn't, if for any reason you didn't get the wind turbine lesson plan and the picture guides for it, send me an email straight after this and I can send it straight on to you. There's no problem at all. Do we have any other questions there? Because I think it's hard when there's no, we went through it quickly. Do you have any other questions you want to ask me? Thank you. Yeah, when I think, do I have any other hints or tips? No, I won't. I'll get tempted to jump into. Look, if you did, what I would say, and I'll give it to you as an option, but it's totally up to yourself. I'm around, I'm working from home today and next Tuesday. So if you did want me to do another session, engineers are coming in to talk to you about wind energy and blade design. I'm happy to do a session that's just running through the construction of the wind turbines and how I do it and what I look at. But I'll offer it, but if you don't have time to join or you don't want to join, that's absolutely not a problem whatsoever, like not in the slightest. And I hope you enjoy it. The one thing I suppose I would ask, I hope I'll stop our recording there. Stop the one